So moving on to number 10, the best movie of all time. The correct answer here is The Cowboys, starring John Wayne. John Wayne, there are a lot of great John Wayne movies. I particularly prefer El Dorado or Hellfighters, but The Cowboys is also a good one. Moving on to number 11. At a given locus with dominant genetic action in 2 alleles, if a suspected carrier passes a progeny test, what does that mean? So we have that animal's initial PO. Okay, that is a value. And then it passes a progeny test with a certain level of confidence. Let's just cross out C because we know that that probably will never reach 1 and that it can't be negative. And if it has an initial probability and it passes the progeny test, the probability is not going to be 0. So since it passed that progeny test had a level of confidence, and that level of confidence will increase the probability of being homozygous dominant and given that clean test based upon that level of confidence. So the correct answer here is A. Moving on to number 12, maternal heterosis for a character. So we're talking about maternal heterosis. Dr. Riley talked a lot about maternal heterosis and the importance of it. So we know for sure that it is favorable. That is a fact. It is super favorable. And if we're talking about heterosis, we know that we are talking about crossbreds. Okay, so definitely not purebred. And same here. There was a typo, but that was correct on the test. So maternal heterosis for a character is the favorable crossbred contribution of a crossbred female to her crossbred progeny. It's all about crossbreeding when it comes to heterosis. Moving on to number 13, this goes all the way back to our breed lectures. A prolific breed of sheep, white, fine wool, known to have the F gene. So fine wool and F gene. We know it's not Dorset and Rambouillet or Merino because they're not a prolific breed of sheep. This F gene indicates the Barula Merino. Number 14, maternal hog breeds include. So we know that Duroc is not a maternal hog breed. We know that Hampshire is not a maternal hog breed. And we know that Putrin is definitely not a maternal hog breed. So the correct answer here is Yorkshire, Michon, and Landrace. Number 15, which of the following is true about birth differences in birth weight between, which of the following is true about differences in birth weight between sexes and Bos indicus sire calves out of Bos stems at birth compared to reciprocal crosses? So we're talking now about our Bos indicus, Bos taurus reciprocal crosses. So males and females tend to be heavier in the Bos taurus sired crosses. That's not the case. Quite the opposite. There is no difference in birth weight between sexes and Bos indicus sired calves versus Bos taurus sired calves. That is not the case either. There are minimal differences in birth weight between sexes and Bos taurus calves. That's good. Bos indicus sired female calves tend to be much heavier than the male calves. That's not true. There are minimal differences in birth weight between sexes and Bos taurus sired calves. Yep. And the Bos indicus sired calves tend to be much heavier than the female calves. That is correct. There was another answer. There are large sex differences in birth weight in both Bos taurus sired calves and Bos indicus sired calves. That is not correct. So the correct answer for this one is that there are minimal differences between sexes in Bos taurus sired calves, and then in Bos indicus sired calves, the males tend to be much heavier. Moving on to number 16. What is the probability that a bull's transmitting ability for any EPD is less than 2 possible change values below the EPD? So let's draw our standard distribution curve, which I'm sure y'all are tired of. We have our EPD in the middle. And we know this is going to be 1 possible change value below. And here's 2 possible change values, or standard errors, but when we talk about EPDs, we call them possible change values. We know that there's a 50% chance that it's below the EPD. We know when we move down 1, that's 16%, and then we move down 2, that's 2.5%. So the correct answer for 16 is E. Number 17, no progeny test is available for a boar suspected of being heterozygous at a given locus with a dominance as a genetic action in 2 alleles. The bull's sire has a probability of being homozygous dominant of 0.5. The bull's dam has a probability of being homozygous recessive of 1. So we know this dam is homozygous recessive. This boar's probability of being genotype big D, or his PO, is what? And so if we know that his dam is a homozygous recessive, that dam is going to give a little d to him no matter what. That's the only choice she has to give. So we know at least he has a little d from his dam. We don't really know what he could get from his sire because he only has this probability, but since he has at least one little d from his dam, the probability of him being homozygous dominant at this locus is 0. What is the expected fraction of direct hybrid vigor in advanced generations of a composite? So let's think about advanced generations of a composite. We know we're breeding a 5/8 Angus to a 3/8 Brahman, and we breed it to the same thing. And that gives us the same thing. I'm just going to do quotes. So there's two ways you could do it. You could do it the Punnett square method. I prefer to do that because I can visualize it better. Oops. 5/8 Angus, 3/8 Brahman, 5/8 Angus, 3/8 Brahman. So these boxes with Angus do not matter. Same with Brahman, that's not breed heterozygous. So we have 5/8 times 3/8 and then another 5/8 times 3/8. So if we do it in the equation form, we do the amount of Angus in the sire times the amount of Brahman in the dam, then the opposite, Brahman in the sire times the amount of Angus in the dam. And that is our fraction of direct hybrid vigor. That's what we're talking about here. We would multiply it by our direct hybrid vigor for Angus and Brahman if we had one, and the correct answer here is E. That is what this equals. So P is equal to G plus E plus G times E. So we're looking for something that is true about this statement. So it's not phenolin, so that's definitely not an answer. We know that genetic environment interactions is not rare. Environment trivially influences what's seen. That's definitely not the case. G is comprised of additive and dominance effects, but we can't forget epistatic effects. So the correct answer is B. Not all combinations of genetic and environment influence have the same effect on phenotype. And then lastly, the correlation and regression coefficients of two variables x and y. All the following are correct except I think we've seen this problem many of times, and we know that the correlation coefficient is not the covariance divided by sigma squared a, but we know it has a parameter space of -1 to +1, and we know that the correlation coefficient and regression coefficient can be expressed as a mathematical function of the other. We know that the regression coefficient is the change in one variable per unit change of the other variable, and we know that it has a parameter space of -infinity to +infinity.